Bismillahirrahmanirrahim. Assalamu alaikum. I am Fakhr Lodi and this is our 13th lecture of Formal Methods for Software Engineering. In the previous lecture, we were discussing how to use horse logic for constructing programs. तो जिन चीज़ों को हम इससे पहले देख चुके थे वो हमने ये देखा था कि किस तरीके से आप सीक्वेंशियल स्टेटमेंट्स जहाँ पर कोई आपकी कंडीशंस ना हो उसको आप किस तरीके से होस्ट लॉजिक से किस तरीके से आप कैलकुलेट कर सकते हैं. ऑल यू नीडेड टू डू वाज गिवन द प्री एंड पोस्ट कंडीशंस you could simply apply the assignment axiom to calculate the different statements. और इस सिलसिले में हमने we saw a few examples there. So that is a straightforward kind of mechanism. Given the pre and post condition, you could easily do that. For the selection statement, we saw Dijkstra's guarded command. The guarded command is very similar to our if statement. The only difference really is that all the different clauses in the guarded command, they are mutually exclusive. They are not supposed to be mutually exclusive, or if they are not mutually exclusive, then that means that if more than one guards are evaluated to be true, then arbitrarily any of the clauses can be executed. So if statement में आपकी if else जो हैं they are mutually exclusive. Guarded command में आपके guards they are all evaluated, and if more than one are evaluated to be true, so उसके मुताबिक उसको arbitrarily आप उस particular clause को उठा सकते हैं और वो execute कर सकते हैं. दूसरी इसमें जो important चीज़ है वो ये है कि when the guards are evaluated, at least one of the guards has to be evaluated as true, otherwise it is an error condition. So हमारे if then else statement में ये ज़रूरी नहीं है कि आपने अगर if की statement कुछ construct की हुई है और उसमें मुख्तलिफ जो conditions हैं तो हो सकता है कि वो कुछ ऐसी situation बने कि उनमें से कोई भी branch आप ना ले रहे हों. So for a Dijkstra's guarded command, that would be an error, that would be a problem. So हमें इस चीज़ को देखना होगा, and इससे हमें proofs में ज़रा आसानी हो जाती है. You could write your if statements using Dijkstra's guarded command very easily, and we saw that also. तीसरी जो चीज़ हमने देखी थी वो ये थी कि जब आपके पास loops हों, in that particular case, how do you actually build the loops? ये loops जो हैं ये ज़रा थोड़ा सा ज़्यादा involved process है. जब आपकी if statement जो है जो selection की statement है उसमें once you have done the analysis, you have identified the different branches, उसके बाद काम straightforward हो जाता है. Once you have identified different branches, once you have done that, आप उसके पास उसके guards आप identify कर लें, and the rest is a straightforward mechanism. वो हमने बहुत ज़्यादा डिटेल में पिछली बार देखा था. बट इन द केस ऑफ आवर लूप्स ये ज़रा इतना स्ट्रेट फॉरवर्ड मैकेनिज्म नहीं है. वंस अगेन यू हैव टू डू अ लॉट ऑफ एनालिसिस, और आफ्टर द एनालिसिस यू हैव टू कम अप विद अ नंबर ऑफ डिफरेंट थिंग्स. वो कि ये हम पिछले लेक्चर में इस चीज़ को डिस्कस कर चुके हैं, बट आई वुड लाइक टू रीट्रेट once again look at it so that the concept is very clear when we try to solve the problems today. So let us look at what are the things that we need to do in the case of our loop statements when we have loops. So we have these number of things to take care of. Obviously, for any program, we need to have the pre and post conditions. So those pre and post conditions, they would be given, or at least you have a starting point. So let's assume that we have our precondition as P and the post condition as Q. The next thing that we need to do is, remember for problems involving loops, we have to have an invariant condition. ये invariant condition जो है, once again, this is the key to the specification of loops. Without the invariant condition, the loops cannot be properly specified. Invariant condition, once again, क्या चीज़ है? मैं बार बार इस चीज़ को ज़रा थोड़ा सा रिपीट कर रहा हूँ. ये ज़रा थोड़ा सा मुश्किल कॉन्सेप्ट है और शायद मुश्किल से समझ आता है. इन्वेरिएंट कंडीशन ये है कि throughout the execution of this loop, after each and every iteration of the loop, this is the condition that remains constant, that stays the same. So ये आपकी progress जो है इन्वेरिएंट कंडीशन के बगैर हो नहीं सकती. अगर आपकी लूप इस तरीके से है कि उसका बिहेवियर एक chaotic है बिहेवियर है, in that particular case you would not have a proper invariant condition and you will not get your final objective. So जो invariant condition जो है, that has a very close relationship with your postcondition. So we must have an invariant condition for every loop, and we have to do that analysis. Then the next thing is the bound function. बाउंड फंक्शन, वंस अगेन, पिछली बार हमने इसका जिक्र किया था. बाउंड फंक्शन क्या चीज़ है? बाउंड फंक्शन आपको एक अपर लिमिट प्रोवाइड करता है. दिस इज अ नॉन नेगेटिव इंटीजर वैल्यू. इट गिव्स यू एन अपर लिमिट ऑन द नंबर ऑफ इटरेशंस. इट गारंटीज कि ये जो बाउंड फंक्शन जो है, इसकी नंबर ऑफ इटरेशंस लूप की जो है, ये इससे ज़्यादा नहीं होंगी. एंड हमारा जो इटरेशन जो है, हमारी लूप की जो बॉडी जो है, उसका मैकेनिज्म कुछ इस तरीके से होना चाहिए कि विद एवरी इटरेशन द वैल्यू ऑफ द बाउंड फंक्शन इज डिक्रीज्ड. सो दैट मीन्स वी आर कमिंग क्लोजर टू दैट कंडीशन वेयर वी विल टर्मिनेट द लूप. सो जब ये बाउंड फंक्शन की वैल्यू 0 पे पहुंच जाएगी, या अगर कोई नेगेटिव वैल्यू हो जाती है, then you will automatically come out of the loop. So the bound function gives you an upper limit on the number of iterations that you will have in a particular loop. So ये bound function के लिए आपको थोड़ा सोचना पड़ेगा कि हमारा bound function क्या है. Next is the termination condition of the loop, and let us call it this Boolean variable done. This termination condition क्या है? Termination condition is that condition that you need to check to exit the loop. And this termination condition in many cases is very, very closely related with the bound function. Or you can say the bound function is very closely related with the termination condition. So जो variable जो आपके program के हैं, जो इस loop की execution को control कर रहे हैं और उसकी number of iterations को control कर रहे हैं, वो बाउंड फंक्शन और डन का जो आपका वेरिएबल है, इसमें दे विल बी प्रॉपर्ली यूज्ड दोनों के केस में. या बाउंड फंक्शन और डन जो है, शायद वो बहुत सारे केसेस में वो एक ही चीज़ बन जाती है, या उसकी शक्ल करीब करीब एक जैसी आपको नज़र आएगी. सो द डन कंडीशन कि किस वक्त यू आर डन, यू हैव टू बी एबल टू आइडेंटिफाई दैट कंडीशन ऑल्सो. एंड फाइनली वी हैव this initialization statement. So we start our loop, or actually a program which has a loop with the precondition P, and then after executing certain statements we come to this point where we have our loop. In this loop we have the invariant condition. And in this invariant condition, that invariant condition has to be satisfied before and after the loop and during the execution of the loop after each iteration. So that means that invariant condition is sort of a precondition for the loop, because it has to be present before you actually start executing the loop. So what we do is we have to find the set of statements S that will give us the invariant condition given the precondition P. And once again, if we assume that there are no loops between the starting point, that is the precondition, and the start of the loop, that is where we will get our invariant condition, then we can very easily calculate. It will either have the selection statements or it will have some kind of assignment statements. So we can use those to calculate the set of statements to have our initialization condition there. So we have to calculate this set of statement S. So in order to do or write a program which involves loops, we have to do these 4 or 5 things. That is, we start with the precondition and we have our postcondition. So these are the 2 givens. Then we find the loop invariant, we find the bound function, we find the done condition, and we find the statements, initialization statements, that will take us from the precondition to the loop invariant just before we start executing the loop. So what are the relationships among all these different things? Let us once again try to look at those. So first of all, we have our postcondition. Remember that we have our invariant condition which must be true before the execution of the loop, during the execution after each iteration of the loop, and after we are done with the execution of the loop, this invariant condition has to be true. And then we have our done condition. We come out of the loop when this condition is true. So when we come out of the loop, that means this is going to be true. So we have our invariant condition which has to be true when we come out of the loop, because it has to be true after each iteration of the loop. So that implies that when we have these 2 conditions, that should give us the postcondition if our program is correct. So this is the first set of kind of an equation that we need to understand, the relationship between the invariant condition, the done, and the postcondition Q. Now let's look at the second condition here. The invariant condition gives us 2 things. Either we are done or we are not done. If we are not done, in that particular case, the bound function is going to be greater than 0. That is a given. When the value of the bound function is less than or equal to 0, that means we have to come out of the loop. The bound function, the value has to be positive for the loop to continue. So, and the other thing is that, so this says that, you may be inside the loop. And this says that, when you're done, this variable, the value of this variable done is going to be true. And in that particular case, you are going to be outside the loop. So this invariant condition implies that either of the 2 is going to be true. So as long as this invariant is true, and invariant has to be true before and after each iteration of the loop, this has to be true, and hence we must have either one of the 2. So we must have this whole proposition as true. And finally, this is our initialization statement or set of initialization statements. Our precondition should give you invariant after you have executed this set of initialization statements. So this is the relationship between the precondition P and invariant and our initialization statement. So as you can see, the bound function the invariant, the initialization statement, and the done variable, they are all sort of related, and they are related through different kinds of implications. Okay, so we discussed that in the last lecture also. Then we have our final thing, that is the body of the loop. The body of the loop has to be such that the invariant condition stays invariant throughout the execution of the loop. So what does that mean? That means we have the loop body. The loop body, we start with the invariant condition, and in order to get inside the loop body, we must have this invariant and not done, and the bound function has some value c. After the loop is executed, so that is our loop body T, what we must get is number of different things. We must have our invariant condition. This invariant condition has to be intact. Now, after this statement or this body set of statements has been executed, we have two conditions. Number one, either this done is true, that means now we come out of the loop, or the loop body must ensure that the bound function, whose initial value was c, after execution of this set of statements, the value has to be less than c. So that means the value of the bound function is decremented after each iteration. So what we are saying here is the body of the loop, the set of statements that constitute the body of the loop, has to be such that either after executing, you have this condition in which the Boolean variable done is true, that is your end condition, so you come out of the loop, or if you do not come out of the loop, you have the bound function, the value of the bound function is decremented. So the statements that constitute the body of the loop, they must ensure this thing. So these are our basic starting points, and these are the things that we need to remember in order to develop a program which involves loops, and with the help of this pre and post conditions and different axioms, different kinds of tools and mechanisms that we have seen. In the last lecture, I asked you to work and think about a program in which you had to add the values stored in an array. So it is a very simple function. You must have written that function a number of times. But what we want now is we want all these different things for that particular function. So what are those different things? What we have to find out is we have to have the pre and post condition. And then we have to, find out the bound function. We have to find out the done condition. We have to find out the initialization statement. We have to find out the loop invariant. I'm not going to write the code. I'm not going to write the body of the function, but I'm only going to show you these different things that we must have. So let us try to see how can we develop these different things, or how can we actually calculate these different things. So in order to calculate these things, we need to have our starting point. So what are our starting points? We have, let's assume the array is X, and its first index is X first, and the last index is X last. ये रिमेंबर कि हम एडा की नोटेशन को यहाँ पर हम यूज़ कर रहे हैं, एंड इट इज़ वेरी कन्वीनियंट. इट कुड बी एनी नंबर. So with these we will be building our different variables and different propositions using these 2-3 different starting variables. So what we have is, we have the array X, the first index, and the last index, we have the precondition, we saw the precondition previously, and that precondition was true. I will come back and revisit and discuss this true condition. The postcondition in this particular case is once again trivial. So what we need to do in this particular case is, we have to have a variable in which the result is stored. So let us assume that variable is sum. So sum would have the total of all the elements in that array. So that is what we are going to write. So the postcondition is, our variable sum is equal to sum of sigma I from x first to x last x I. So this gives us the postcondition. This is our desired output. Now we have to find out the loop invariant, the bound function, and the done condition, and obviously the statements to initialize so that we get the loop invariant. So first of all, let us concentrate on the loop invariant. The loop invariant has to have a close relationship with the final outcome, that is your postcondition. So that means, you have to have a situation in which, the invariant stays constant, and with every iteration, it takes you closer to your final condition. So the loop invariant in this particular case, we have already seen. So I will simply write that down. And that loop invariant is, that is, we go from the first to the ith index, and we have this sum of all these elements starting from the first to the ith index in this variable sum. So that is our loop invariant. Sigma j goes from x first to our I, and we have this condition. So see, the two conditions, they are almost exactly identical, except that in this particular case we stop at the ith index, and here we complete the entire array. So these are the only differences in this particular case. The more interesting cases are the bound function and the done condition. So what are the bound functions? Bound function, as I already mentioned, bound function gives you an upper bound on the number of iterations on the loop. How many times this loop is going to be executed. So we have this array. the size of the array is the last minus first plus 1. So the number of times this loop should execute is equal to the size of the array. But here we have a small hitch, and I will write the bound function slightly differently, and you can see that why I have done it. We can talk about it a little later. So the bound function is a function that tells you, how many times the loop is going to be iterated, and that means, it gives you a value. After each iteration, this value should be decremented, and you should have a new value. So what are the variables involved here? Obviously, we stop at our last index after we have executed, after we have added the value stored at the last index into the sum. After that, we will stop. So how do we know that we are done? So this done and bound function, they are going to be closely related. So let me first talk about this done, and then I will come back to the bound function. As I said earlier, they are very, very closely related. So the done condition is, I have my index I. This is the index. This is, where I am. I stop when this index I is equal to x last. So at that time, I am done. So I can write this done is equal to this x last the relationship between x last and I Now we have to look at this particular condition, less than or equal to. So when x last is smaller than I could have written it like this. I have to see, whether I need this less than or I need this less than or equal to. So let us try to look at it, and let us try to discuss this particular case. Let us assume that I have this array here, and I have the elements in this array. So this is my first index, and this is my last index. When the value of I is here, am I done at this point in time or not? When the value of I is here, that means I still have to, now looking at this condition, invariant condition, I have to find out, what is my invariant condition. The invariant condition says that I have the sum of all the elements from first to I. Now the question is that invariant condition true, or do I need to change the invariant condition here? In this sum, I will have the sum of, when I come to this point, the value of I is, x last. Before I have actually executed the last iteration in the loop, the last time I have executed the loop body, I would have all these elements in my variable sum. So this, all the elements stored here would be present, the sum would be present in this variable sum. So the last time that I execute this statement I, this loop body, I will add this to this sum also, and that will complete my entire array. So this is one way of looking at it. So when I look at this invariant condition in this particular case, if I write I here, that means when the value of I, at that time, it should include all the elements from first to I. So there are two different cases here. I have either the value of I of the variable or the array, which is from x first to I minus 1, or the second case is I have either to I. The way I wrote my invariant condition was that, this was what I wanted to have in my variable sum. So either I change my invariant condition here, or I change this statement here. If I keep my invariant condition like this, that means, the statement here would be that, as soon as, I have this thing equal, I should come out of the loop. So my condition here would be, should be, in that particular case, that I use this as my done condition. That is, x last is less than I. Because when x last is equal to I, that means according to my invariant condition, I would have all the elements, the sum of all the elements in my variable sum, and that means I should now come out of the loop. So this is, as soon as it is equal to the done, it is equal to I here, I'm done. So this is one way of looking at it. If I had written less than or equal to, in that particular case, I needed to change my condition here, and it should be I minus 1 that I have written above there. So, the two, they have to go with each other. They go hand in hand with each other. I could use either one of the two. कोई उसमें मुझे फर्क नहीं पड़ता. बट जिस तरीके से भी मैं लिखूंगा, दोनों का रिलेशनशिप जो है वो आपस में बड़ा टाइट है. दे आर टाइटली कपल्ड, एंड द स्टेटमेंट्स, जो सारी की सारी स्टेटमेंट, इनिशियलाइजेशन स्टेटमेंट एंड द बॉडी ऑफ द लूप, जो कुछ भी है वो उससे रिलेटेड होंगी, वो उसी तरीके से लिखी जाएंगी. सो नाउ लेट अस गो बैक and let us just assume that, this is my invariant condition, the way I wrote it, and my done condition is either this one or that one. They are, both of these, they are equivalent. Now, let me erase this and let me write only one condition, that is x last is less than I. In that particular case, as soon as the value of I is equal to x last, we are done. Now the bound function is the last thing in this, particular case. What is the bound function? The bound function, remember, is very, very closely associated with our done condition. and with every iteration its value must be reduced. So, after I iterations, it gives you the upper bound on how many iterations are left, the maximum number of iterations that this loop can have now. So, important thing to remember is that once again, it is going to be a function of your index I that you have in your loop. So, how do we do that? The bound function can be very easily written. It is, remember, when the value of this bound function is less than or equal to 0, we must come out of the loop. So in this particular case, this is the bound function, x last minus I. So as long as the value of I is less than x last, we are still iterating inside the loop, and as soon as this becomes I is equal to x last, this equation, this statement, the value of this statement becomes 0. So the bound function is equal to this. Okay, so that means when they are equal, the bound function, the value of the bound function will be equal to 0, and then we will come out of the loop. So once again, see the relationship between the done and the bound function. It is using the same set of variables, although this is a Boolean statement and this is an integer statement. So in this particular case, the answer is true or false. In this particular case, the answer is an integer, a number. So as long as it is greater than 0, we are still in business. So we have the precondition that was true, that we wrote as true. The postcondition is the sum of all the variables, all the data inside this array from first to last. The invariant condition from first to I, done when x last, as long as x last is greater than I, we are not done, greater than or equal to I. And similarly, bound function is this value there. So these are the number of different variables that we need to calculate. And this calculation, as you can see, is not automatic. But one thing that you must remember, they are all very closely related. And the bound function, the done condition, they are all sort of driven through the invariant condition. Remember, we said that the invariant condition will give you the bound function and the done condition. So, that has to be kept in mind. And when you are trying to find the formula for these things, you have to remember, you have to try and tie that with your invariant condition. Invariant condition, जब हमने अगर I यहाँ पर लिखा था from first to I, so the bound function and the done, they are related with that. If that were I minus 1, we would need to change it accordingly. Now, once that is done, you need to calculate the body of the loop. I'm not going to give you the body of this particular loop. This is a straightforward thing. Please go ahead and do it yourself. But there is another interesting point here. And that point is, what happens if there is nothing in the array? That is, if the user or the client program passed an array which has nothing in it, that is, the array is kind of an empty set. The first and the last indices, they are overlapping. First is greater than last, that means, there is nothing in this array. It is empty. So what do? We initialize, once again, I'm not showing you the initialization statement, but, and how to calculate the initialization statement, you calculate it yourself. But, let us just assume that what we need to do is, we need to initialize this variable sum to be equal to 0 before we start execution of the loop. So in the case of initialization, what we need to do is we need to initialize this variable sum to be equal to 0. So what does that mean? So we have this sum to be equal to 0. So this is what we need to have before we start execution of the loop. We have all seen that. Now, once again, the question was, what happens if we passed an empty set? When we passed an empty set into the function, in that particular case, the value of sum, obviously, loop will not execute, we will simply come out of the loop and we will go to the post condition. But the value of sum in that particular case is going to be 0. Is that a legal value? When there is nothing in the array, we are saying, the sum of all the values in the array is 0. Is that legal? Once again, that is a question that needs to be answered by a mathematician. But, if you want to have a proper thing, that is, you don't want that kind of situation to occur. So in that particular case, you need to impose some restriction on the input. And what is that restriction? What we need to do is, the problem occurs when x first is greater than x last. When the two are equal, that means, there is one element in the array. So if there is one element, then x first and x last will be equal. And if x last is greater than x first, that means there are more than one elements present. So we don't have a problem in that particular case. But we would have a problem. If that condition is not met. That is, if this condition is not true. If this condition, is true, that is, x first is greater than x last. So we must change our precondition accordingly. What is our precondition in that particular case? The precondition becomes x last is greater than equal to x first. So what we are saying here is, as long as this condition is true, the value that you will get back in this variable sum will contain the sum of all the elements in that array. Now, I will stop in this particular example. I will stop here and will please go back and complete the rest of the work. That is, you need to calculate the initialization statement and you need to calculate the body of the loop. But please remember that you start with this precondition and then you have to have the invariant condition in mind. So use the invariant condition that we have. This invariant condition must be satisfied before and after the loop also. So we are saying, when whatever you initialize the value of I to be equal to x first, for example, when you start the loop, what do you have in there? So that is what you will need to do. So what you need to do is you need to calculate all those different statements, and the rest is going to be very simple. So this is a very simple program, और इसमें आपने देख लिया है किस तरीके से आपको मुख्तलिफ चीज़ों को उनका ध्यान रखना है, and once you do that, there would be no problem. अब जो मैं आपको अगला जो प्रॉब्लम लेके चलूँगा, this is a very interesting problem, और इसकी रिलेशनशिप एक बहुत फेमस प्रॉब्लम से है. आप उस प्रॉब्लम को जब मैं इसको एक्सप्लेन करूँगा तो शायद आप पहुंच जाएं कि इसका ताल्लुक किस प्रॉब्लम से है, और वो प्रॉब्लम आपने कई बार शायद आपने देखा होगा. This problem was proposed and actually posed by the famous computer scientist Dijkstra, or the problem is known as the Dutch national flag problem. The Dutch national flag has three colors: the red, the white, and blue colors. The Dutch national flag problem, is stated as that you have an array. In this array, so this, assuming that this is an array or this is a collection, somehow you have these different balls of different colors. Three different colors. You have the blue color, you have the red color, and you have the white color. What you have to do is you have to arrange these balls, kind of sort it, the array, so that you have the balls in the same color that you have in the Dutch national flag. That is, after you have rearranged these kind of balls, you would need to get this new arrangement. That is, you have the red followed by white followed by blue. Please note here that we do not have the same number of balls in this particular case, but what we need to do is we need to arrange them in the same order that we have in the Dutch national flag. The problem in this particular case is we have to find an efficient solution for that. And what we need to do is, obviously, it would sort of involve some kinds of loops. In this particular case, you will see that this particular problem will involve the selection statement also. So we will also have to find the different choices and different clauses in our selection. And we have to find, obviously, the solution to this particular problem. Problem is very interesting. You can find it, you can sort it, sort of, and then you will have it in this particular order. But the algorithm requires that we have to do it in a very efficient manner. So in this particular case, let me say that we need to do it in big O of n. That is, in linear time, we have to rearrange the balls. All we can do is, we can, iterate through this kind of loop. Let us assume that we have an array, and when we look at the value at any index of the array, that value tells us what is the color of the ball in that particular position. And so we can iterate through this loop and we can find the values. The other thing that we have is, maybe we can have many different indices, and at any given point in time we can swap the values of two balls present. So these are the things that we need to work with. That is, we want to have one iteration throughout the loop. We also have we have this function swap that swaps these two balls. For example, if there is a red ball here and a blue ball here, we need to swap their positions. So we simply apply this function and that will exchange the position. We are not supposed to do anything else. So with this, you have to find a solution to this particular problem. Now, in this particular case, I'm not going to give you the solution today. But once again, what you will have to do is, you have to identify the precondition, the postcondition. So these are obviously your starting points and your termination condition or your objective. You also have to identify the loop invariant. So what will happen when you execute this loop? And once you have identified that loop, you will see, once you have identified the loop invariant, you will see the solution to the problem is straightforward. The bound function obviously is there, how many times this loop is going to be iterated. And as I have told you, that I don't want a solution which is more than a linear time. So you have to work with linear time complexity solutions. So the bound function has to be some function of the number of balls and a linear function of the number of balls. So these are the things that you need to work with. So once you have identified those, then calculate the initial statement and calculate the loop body. So these are what you are supposed to do as homework for today. In the next lecture, I will give you the solution to this problem, and I'll discuss it in detail. This is a very interesting problem, and then I will tell you the relationship of this problem with some very famous problem that you probably would have already seen. I'm sure that you have already seen that problem. But, you know, very interesting, very useful problem, and then, you know, you will see that the solution can be used in many different cases and at many different places. So please do that. Please try to work it out yourself, and then we will try to solve it in the class. Now, once again, reiterating, giving you a recap of what we discussed today. For a problem involving loops, you know, what you have to do is you have to do some analysis. So given the pre and post condition, you have to identify the invariant. You also have to identify the done condition and the bound function. And the invariant condition and the done function, done variable and the bound function, they are very, very closely related with each other. And in fact, you know, they are given, I showed you that how they are actually related. You also have to calculate the initialization statements. So given the precondition, you calculate the initialization statements so that you get the invariant condition. So from the invariant condition, you get the bound function and the done function. And then you calculate the loop body. Loop body should be such that after each iteration, the invariant condition stays invariant. The value of the bound function is decremented, is decreased, or you come out of the loop by, you know, when the value of done has become true. So with that, I will stop today. Inshallah, we will meet again, and hopefully by that time you would have completed the solution to that problem. Till that time, Khuda Hafiz or Assalamu Alaikum.